Greetings, students. Today we're talking about decimal division. Now I know we talked about this in class, and we're doing a little swoop. There it is. But we need to make sure we have a video that explains exactly what we're doing during each problem, and so I can practice a little bit with y'all. So here we go. Please make sure your name is at the top. A lot of people have been forgetting that lately, so I need to make sure you got your name up there. Here we go. Our notes today is that we are going to always begin by swooping the divisor, the outside number, swooping the divisor decimal to the wall. Now, hopefully you guys remember from class, the reason we have to go all the way to the wall is so that we have a whole number. We're used to dividing by whole numbers, but also the wall is the place that we stop. So we need to count how many places we swoop to get to the wall. Second note, we must also swoop the inside decimal. That would be the dividend decimal. The same number of places, and I'm going to explain this a little bit more in a second. Then we're going to divide like normal, and finally we're going to take that decimal elevator and put our decimal in the quotient. Now some of you might be wondering, why does this work? And we did a couple examples in class to show you why it works, but I want to give you another example right here. So the idea here, and please write this down with me, is that if we have 16 and 21/100ths, and we're dividing by 8 and 3/10ths, what would it look like, by the way? It would be 16 and 21/100ths divided by 8 and 3/10ths. With the 16 and 21/100ths top number, the numerator is the dividend, and it's being divided by the divisor, 8 and 3/100ths, the bottom number or denominator. The denominator is the divisor. We need to swoop that divisor decimal to the wall. And why does this work? Why do we get the same answer even though we seem like we're changing the numbers around? And it actually has to do with equivalent fractions. So we know that to make equivalent fractions, as long as we multiply the top, the numerator, and the denominator, the bottom number, by the same amount, then we're good. We've also already talked about by multiplying by 10 moves the decimal once to the right, or really just changes the place values. So what we want is we want this divisor to be a whole number. Well, we need to move that decimal once to the right. So we're multiplying the bottom by 10. We also need to multiply the top by 10. So this is why we have to shift both those decimals in the same number of places. So if there were 2 decimal places, if we had to swoop twice in our divisor, then we would be multiplying by 10 twice, or multiplying by 100. We would have to do the same thing to the numerator to make sure we had an equivalent fraction before we divide it. And this is why it works. Please make sure you have the notes. And if that didn't make sense, maybe listen again and try and understand what we're talking about here. But let's get into some practice problems. The first one I have is 7 and 35/100ths divided by 2 and 1/10. Okay, so let's figure this out. 7 and 35/100ths, that's our dividend. It's the one that's going to be divided by the divisor. So 7 and 35/100ths divided by 2 and 1/10. That's how we need to set this up. I need you to know those terms and know how to set it up. The first number always goes inside this little building or house. And this decimal, we said we're going to swoop to the wall. That only took one place. That's one swoop multiplying by 10. We need to do the same thing to the dividend on the inside. We'll just shift it once, and we'll multiply by 10 that number as well. I like to rewrite this, and I'll say now what do we have? We have 73 and 5/10ths divided by 21. Now we're dividing by a whole number. This looks a whole lot better. 21 goes into 73, let me think, probably 3 times. That'd be 63, or 3 times 1 is 3, 3 times 2 is 6. I can subtract and I get 10, and I bring down my 5. 21 goes into 105 5 times. 5 times 1 is 5, and 5 times 2 is 10. Oh, perfect. That worked out. The last thing we need to remember is take that decimal, put it in our answer by taking that decimal elevator. It just moves straight up into our quotient. Quotient is the answer to a division problem. So we have 3 and 5/10ths. That's our answer here. Number 2, Mr. Schwartz, the model. Oh, there's a model named Mr. Schwartz apparently. Who could that be? I have no idea. Has to walk 136 and 5/10ths feet down the runway. If each step he takes is 3 and 25/100ths feet long, how many steps will he take? If you guys are curious, you should be familiar. 25/100ths, that's a quarter or 1/4. So easy to transition into a fraction. We'll do that later this year. Same with 5/10ths. 5 out of 10 is 1/2. So that's 5/10ths. You could just write it as 5/10, but that simplifies to 1/2. Just thought I'd mention it, but let's get to work on this problem. We're trying to take this total distance and split it into chunks. each step, so this is division. The notes I would take for this that I think you should take are runway is 136 and 5/10 feet, and stride or step would be 3 and 2/5 feet, or 2/5, 3 and 25/100. Sorry. How many strides? This is division again, we said, so it will be 136 and 5/10 divided by 3 and 25/100. And we'll divide. Again, we need to swoop first to the wall, so we'll swoop it once. Twice will get us to the wall. We need to swoop the inside number twice too. And when we don't have anything to fill that second space, we can just fill it with the 0. All right, let's rewrite this question and make it look a little nicer. 325. How many times does that go into? This is 13,650. Oh, baby, this is going to be a big one. 325 doesn't go into 136, but it does go into 1,365. 300 fits 3 times completely into 1,000. We're talking about more than 1,000 though. So let's try 4. 4 times 5 is 20. 4 times 2 is 8 plus 2 is 10. And 4 times 3 is 12 plus 1 is 13. We'll subtract and we get 65. That's easy enough to see. How many times does 325 go into 650? Think about that for a second. You'll realize it's twice. 3 times 5 is 10. 3 times 2 is 6 plus, whoa. 2 times 5 is 10. 2 times 2, oh goodness. 2 times 2 is 4 plus 1 is 5. And then 2 times 3 is 6. So you could see that mentally, or you could just, because 25s are easy to double. 25 times 2 is 50, and 300 times 2 is 600. So could have done it mentally, and you can tell I started to do that and then switch back into step by step. Step by step, get it? Runway. Okay, here we go. We need to put this in a complete sentence, so we'll say, he will take 42 strides. Hopefully your 42 looks better than that. 42 strides or steps. Still, I hope it looks better than that. Yeah, so I need to count my steps because, I'm just like focused when I'm walking down. I mean, whoever this Mr. Schwartz is focused when he's walking down the runway. So probably just counting the steps to know when he gets to the end. Practice problems I'm leaving you with. You're going to have to take notes on that second one. But the first one is 48 and 6/10 divided by 5 and 4/10. So show me your swoop-in. Show me an answer. Number 2, Mr. S ate 14 and 8/500 pounds, LBS is pounds of hamburger, in 5 and 5/10 minutes. That's 5.5 minutes. How much hamburger did he eat each minute? So I give you the total and the total number of minutes, and I want you to break it down into each minute. So hopefully you know what to do there. Best of luck. I'll catch you later.